Nah, just a Q. Just a Q.
Starting? Okay. Oh, I have mine. I have mine. All right. Hi. It's already 7:11. Okay, we are starting our sample paper analysis for 2024 P1 TASMO in 4 minutes. All right. So for everyone who is here already, thank you for joining me today. Let's sit tight and wait for the live stream to start at 7:15. All right. Hello, I see someone saying hi in the chat. Good evening. Thank you for joining me today again for our 2024 P1 TASMO sample paper. So we will be going through some challenging questions today. I did receive a lot of feedback that the questions for this year or for this sample paper is more challenging compared to the previous years. So let's take a look at how to attempt the challenging questions later. All right. So yeah, we shall wait for 2 more minutes and then we will start. Okay, so it's currently 7:13. Let's wait for around 1 or 2 more minutes for more people to join us. Okay, and then we will start our sample paper analysis at 7:15 sharp. All right, so 1 more minute. If you are if you are tuning into this live stream, please get your completed sample paper ready. Perhaps you can have some stationery to take some notes, and we will start in 1 minute. All right. I would also appreciate and anticipate your active participation in the chat. Okay, as we go through the questions. All right, so more and more people coming in. Let's sit tight. Okay, and we will start at 7:15. All right, so let me hydrate myself first. All right, so it's 7:15. Let's start our 2024 P1 TASMO sample paper analysis right now. All right, so good evening, everyone who joined. And if you're wondering, hey, I think I've forgotten this teacher's name. What's my name? All right, so hopefully you still remember me from last week. I am teacher Yong Lang. All right, so today we will be going through some challenging problems in 2024 TASMO sample paper. Okay, so please get ready with me, have your completed paper, have some stationery so that you can mark your answers or maybe make some notes as we go on with this live stream. And most importantly, maintain your good mood and smiling face. All right, let's end off today's live stream, okay, with a good note. So with that, let me have a little go through of the challenging questions of the day. So I have picked 4 questions from section A and 5 questions from section B. So as you can see, question 22 is being highlighted with red over here because this question is extra challenging, okay? So I will spend extra time going through question 22 with you all. Okay, so with that, let's first go through the multiple choice questions that I've selected today. So starting with question 3. Now in question 3, it is again a geometry problem. We have John Say who glued the 3 pieces of paper shown. We have a dark gray semicircle and 2 light gray quarter circles, okay, onto the black circle on the right. So we are pasting these 3 papers onto this black circle. Which of the following patterns could he not obtain? Okay, so actually, be careful. We are searching for the pattern that cannot be obtained. So now, looking at the questions, you will see that, hey, not all pictures have semicircles and quarter circles. What does this question actually mean? Actually, this is a overlapping question. Some of the papers could be overlapping over others. For example, the gray semicircle could be below, and then we paste the light gray quarter circle on top. So some of the papers could have overlapped with each other, and we would need to identify or deduce where is the position of each of the 3 pieces of paper. How do we do that? Well, here's my little trick for you. Whenever you see a overlapping question regarding overlapping of shapes, try to trace out where each piece is at. Okay, so how do we do this question using this trick? Let's first take a look at the option A. Option A, we have a dark gray little area over here and 2 light gray areas that are clearly our quarter circles. So let's perhaps label down, okay, we have 2 quarter circles over here. 1 quarter circle and another quarter circle. Whoa, very off. So let me draw again. Another quarter circle. But here comes the question. Where is my semicircle? Why is there only such a small dark gray part here? Well, it's because part of the semicircle could have been overlapped by the 2 light gray quarter circles. All right, so what do you think? Where should the semicircle be? Well, we can actually try to trace out the semicircle. For example, the semicircle could be somewhere over here. All right, so yeah, the semicircle could look somewhere like this. So you can see that now, after some overlapping, we can actually form the figure A. So is A my answer? I can obtain A. Is A my answer? Right. What do you think? Well, the question says not obtain. Since we are able to obtain A, well, we cannot choose A. A is actually not the answer we want. Now let's take a look at B. Wow, I see a lot of y'all typing B, 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 B. B. Can we form the figure in B? Let's take a look. We have 2 dark gray areas over here and 2 light gray areas over here. So it's clear that these 2 light gray areas, again, they form my quarter circle. So we have 1 quarter circle, another quarter circle. So identify where they are first. Now I'm left with my semicircle. Where is my semicircle? Now, I see that there is a bigger dark gray area here and a smaller dark gray area here. Could it be perhaps that I cut away the semicircle into two parts and then combine them together? Maybe not. The question didn't say I cut the papers, right? So I assume it's the entire semicircle being pasted somewhere. So the area that is formed by the gray semicircle should be continuous. But if it's a continuous area, I want to connect this area and this area. It should be something like this. Now, do you think this is a semicircle or is it more than a semicircle? Right, it is actually not just a semicircle, it's slightly more than the semicircle. So actually, can I choose B as my answer? B is my answer because I cannot form such a large area using my semicircle. So I cannot obtain this figure. Therefore, my answer is B. All right. So by tracing out the areas or each piece of paper, you can identify, hey, is this the correct shape or is it not supposed to be this shape? Let's take a look at C, okay, quickly. First of all, we have a quarter circle over here. Of course, one of them. Where is the other quarter circle? I only see part of it here. Well, part of this quarter circle could have been overlapped by this dark gray semicircle on top. So maybe it should look like this, but then part of it is covered or overlapped by the dark gray semicircle. So where is the semicircle, you might ask? So the semicircle, let me change my color. It starts from here and it perhaps could end at here. So as you can see, yep, if my semicircle is arranged like this, my quarter circles is arranged like this, we can actually obtain the patterns by some overlapping. So C is, of course, the pattern that we can form. How about D? D is even simpler, actually. We have a half circle or a semicircle that forms this part over here. Okay, this is a semicircle, very clear. How about the two quarter circles? They are just over here and here. Okay, very clearly seen. So of course, I can also form D, and therefore my answer is B. All right, so which of the patterns cannot be obtained from overlapping? Trace out each piece and then check your answer. All right, so what do you think in the chat? I see a lot of confident answers. Seems like question 3 is still okay for y'all. Let's perhaps take a look at question 8 then. Question 8 has no numbers at all. Oh goodness, what does this question even mean? Now, let's read the question together. The question asks, which of the following results in an even number? Okay, so it is either the sum of an even number and an odd number, difference of even and odd, sum of 3 odd, sum of 4 odd. Well, there are no numbers, all right? So how do we attempt this question? Now, to really even try this question out, I suggest we first look at the definition of odd and even numbers together, all right? So let's see. First, we'll talk about odd numbers. Now, can you all type in the chat how many gloves are there in each row? Or what are some examples of odd numbers that you can find? For example, how many gloves are there over here? Oh, I don't want letters. I want to see how many gloves are here. What number of gloves are there? What number of gloves? Is it 2 gloves? I mean, this is easy to count, right? There should be, 2, 3, 5, 7, 9. Are you sure it's 2? There's only 1 glove here, right? Then 3 gloves. Then, how about the next one? How many gloves are there? Give me all the numbers. Okay, 1. Yep, the first one is 1. Second one is 3. Third one is 5. Okay, fourth is 7 and 9. So these are examples of odd numbers. But what do you notice? I have gloves over here, right? Are all the gloves in pairs? Usually when we buy gloves, we buy them in pairs, right? We want to keep both our hands warm. But are all the gloves here in pairs? Is there a lonely guy over here? Yes, I see a lonely guy. How about in 3 gloves? There is a lonely guy as well. Okay, 5, you see there's another lonely guy that is not in pairs. 7, you see, not in pair, it's another lonely guy. Finally, 9, another lonely guy. So what do you notice? Whenever I try to arrange an odd number of gloves in pairs, I will get a lonely guy at the end that is not in any pair. Okay, it's not in any pair. It is by itself, alone. So that is what characterizes odd numbers actually. Odd numbers are numbers that have a lonely guy. So what do you think even numbers mean? Are there lonely guys in even numbers? Let's check. Okay, can you count for me how many gloves are there in each row? Give me all the 5 numbers. Okay, how many are there here? How many are there here? How many are there here, etc. Okay, there are. I see somebody trying to give me the answers. There are 2 here. Okay, what else? 2, 4, 6, 8, and 10. Okay, there are 2, 4, 6, 8, 10 gloves, and these are all my even numbers. Now, when I'm talking about even numbers, let's look at the gloves. Are they all in pairs? Ooh, you will notice that they are in pairs. All right, so they are in pairs, and then are there any lonely guys? There are no lonely guys, right? Okay, there are no lonely guys in this case. Everything is in pairs, and this is why even numbers are called even, because if you try to arrange an even number of gloves in pairs, there will be no lonely guys. So it seems that this lonely guy is very important in defining whether a number is odd or even. With that, let's take a look at question 8 again. Which of the following results in an even number? If I want an even number, will there be any lonely guys? Will there be lonely guys in an even number? Give me some answers in the chat. Even numbers, will there be a lonely guy or will everything be in pairs? Okay, somebody said no. So do you really think it's no? That's right. There are no lonely guys in even numbers. Okay, so how do we check whether a number is odd or even? We try to check. If there is a lonely guy, then it is an odd number. If there are no lonely guys, then it is an even number. So let's just check out where the lonely guys are. Now in option A, the sum of an even number and an odd number. That means I am trying to add an even number to an odd number. So even number, is there a lonely guy? There are no lonely guys, right? We just talked about this. How about odd number? Odd number has a lonely guy. So let me label out this circle as a lonely guy first. Even number, everything is in pairs. There are no lonely guy. Odd numbers, there is a lonely guy. So if I try to add an even number and an odd number together, will there be a lonely guy? Yes or no? Will there be a lonely guy? Everything is in pairs here. In odd number, there is a lonely guy. So at the end, will there be a lonely guy? Will the lonely guy still stay lonely, or can we find a partner for him? Yes, there will still be a lonely guy, right? Good job, Kiana, in the chat. Okay, why do we say it is it is still lonely? Because everyone else is in pairs. Okay, only one lonely guy is still going to be lonely. I cannot find another partner for it. So since there is still a lonely guy, the result will be odd. Okay, so A is not my answer because I want an even result. What if I look at B instead? The difference between an even number and an odd number, which means I take an even number, take away an odd number. What do you think? Is it even or odd? This time I have no lonely guys at the beginning, but I have one lonely guy that I need to take away. Is my answer odd or even? Type it in the chat below. Is it odd or is it even? Even minus odd. Okay, even plus odd is odd. Surely even minus odd is, is it odd or even? Okay. Oh, a lot of people are already giving me the answer. Okay, so, wow. Okay, y'all are so confident. And right, I see some correct answers. It's odd again. Why is it odd? Now, even number, there is no lonely guy, right? But I want to take away one lonely guy. If there's no lonely guys, how can I take away a lonely guy out of nowhere? But even though there are no lonely guys, there's actually pairs. Okay, so what if I take one pair from an even number and then I break them up? So I have one pair, I break them up. Now they become two lonely guys. They broke up with each other. They are no longer partners. Two lonely guys now. I take away one lonely guy. So I am left with one lonely guy. So therefore, the result at the end is also odd, and B is not the answer. How about C? C says the sum of three odd numbers. Aha, this time I have more odd numbers. Odd plus odd plus odd. Okay, now you might say, oh, okay, odd plus odd is even, even plus odd is odd. That's also fine. And whoops, I already spilled my answer. It is odd. Okay, but then why is it odd? Besides the explanation, three lonely guys, and we don't want that many lonely guys. So what can we do? Take a look at the yellow box here. What can we do? We can pair up the odd numbers. Okay, so there are three lonely guys. Let's try to pair them up together. Two of the lonely guys can become a pair, so they are no longer lonely. But what is lonely guy? Do we have a partner? Do we have a partner for this lonely guy? There's no partner. So unfortunately, this lonely guy still stays lonely, and therefore the result is odd. C is not the answer. So that means D is the answer, right? Let's check. Okay, this time we have four odd numbers. Odd plus odd plus odd plus odd. Okay, let's check. Is it still odd, right? So if I have an odd number, I must have a lonely guy. Okay, so lonely guy, lonely guy, lonely guy, lonely guy. And what do I do with these lonely guys? So many lonely guys. We try to pair them up, right? I see somebody mentioned in the chat, pair them up. So I see two lonely guys here, I can pair them up. So these two are no longer lonely. This lonely guy and the final lonely guy, I can also pair them together and they are a pair now, no longer lonely. Do I still have any lonely guys? No, because everyone here is in pairs already. Even the lonely guys are now paired up. So this means no more lonely guy. My result must be odd or even. Right, okay, somebody already gave me in the chat. It is even, great job, okay? So I want an even number. I found the even number. My answer is D. Okay, so this question, if you really cannot understand lonely guy things, don't worry. Just give an example. Okay, for example, the sum of four odd numbers. Well, one is an odd number. What if I just add four ones? It gives me a 4, right? Okay, 4 is even, so my answer is D. All right, this is just another technique you can use in certain competition questions. All right. So without further ado, let's take a look at question 13, which is a very interesting question. Now, we all know that this is a net of a cube. I can fold this up to form a cube. The problem is there are 4 cubes over here. Which cube can be made from the given net? Okay, do you have the answer for me? Which cube can I make from this given net? Okay, type in the chat box below. What is the answer that you found? Ah, I see some answers here. Oh, people say it's D. Is it really D? Let's take a look. All right. Let's start from A. Okay, so from A, there are 3 faces over here. Are these 3 faces all in the cube? Well, they seem to be. So let's actually just check. How do we do this question? When we want to match nets to cubes or otherwise, we just start from one face. Even though there are 3 faces to look at, we just start from one of them. Fix it as my special face and then check its adjacent faces. And when I check, don't just check whether the face is correct or not. We also need to check if the position is correct, because even though the shape on the face is correct, it might be orientated in a wrong way. All right, it might be rotated, it might be upside down. We don't want that. We want exact matches. Okay, so let's check one by one, starting from A. So in A, we notice that there is a triangle, a rectangle, and a black circle on the 3 faces. So which one should we choose as my special face? I will say choose the black circle as the special face because it is rotationally symmetrical. In other words, no matter how I rotate the black circle is still a black circle. So I will choose A as the part to talk about, or rather the circle on top as the part to talk about. So what if the black circle is on top? My black circle is on top. Let's take a look at the face on its right, okay? This face is next to the face with a black circle. We have a rectangle at the bottom of the face, okay? If you really cannot visualize it, draw it out again this time. What will happen if you unfold this cube? Okay, you will have a black circle on the left, and then on the right, we have a black and white rectangle pattern like this. Now, tell me, in the net, we have direction 1, direction 2, direction 3, and direction 4. Which direction has such pattern over here? From the black circle, is there a direction that can give me this sort of rectangle at that exact position? 1, 2, 3, 4. Which one do you think matches? Type it in the chat below. Now, this is a little trick question, okay? Do I have it 1, 2, 3, or 4? Oh, somebody said 1, somebody said no. Well, you all are half correct. For those who said 1, you are half correct. In 1, indeed, we have a black and white rectangle situation going on. But if you try to orient these two faces horizontally, that means if I try to rotate this part, these two faces, rotate together towards the clockwise direction, what do you get? You will actually get, on the left side, a black circle, that's for sure. But on the right side, is my rectangle like this? Actually not. It will look something like this. Okay, the white rectangle is entirely sticking to the other face. Whereas here we have half white, half black. So these two obviously do not match. So we cannot form cube A from the net. So we know A is definitely wrong. Okay, so for those who say direction 1, you are half correct. Okay, because even though I can find a rectangle over here, but the orientation or the direction of the rectangle is different. So I cannot form the cube from this net. Okay, so let me erase everything and we will look at B instead. B, we have a black circle and a white circle next to each other, okay, like this. Is there a black circle and a white circle in the net? Is there? Ah, yes, of course, that is right. They are over here. Black circle on the right, we have the white circle. They are adjacent to each other. So I can see these two adjacent faces. Let's just check the front face left, which means from the black circle, I move on to the front. Okay, if that's the case, black circle, go to the front. Should look at direction 1, direction 2, or direction 3. Which direction should I look at if I want to find this face? Type it in the chat below. Oh, somebody say direction 3. Are you sure? Are you sure? Okay, if you look carefully, my red arrow, if it's pointing to the right, then my blue arrow is pointing down or to the front. If you try to rotate the arrows, you will see that which direction will the blue arrow be turned to? Will it be direction 1, direction 2, or direction 3? I'm looking at the direction. Somebody said direction 2. Yeah, direction 2, we have a rectangle face here. But is this face going to be what we get when we look at this direction? Oh, okay, some say 1, some say 2. Okay, actually, if I rotate these two arrows, I will get my red arrow pointing down, okay, just like in the net. And the blue arrow I rotate together, it will be pointing to the left. So actually, I should look at direction 1 to check, is my face correct? However, if you look at direction 1, this is a face with a triangle. But this face has a rectangle. Do they match? They don't, right? If they don't match, then is this cube able to be formed from the net? Here is a rectangle. But if we look at the net, this part is actually a triangle. Do they match? They don't match. So answer is not B. We are left with C and D now, okay? And E is not an option available. So let's look at option C to check. In option C, we have, okay, a black and white rectangle on top and a white circle on the right. Okay, are you able to find these two adjacent faces? Starting from the black and white rectangle, black one on top, okay, and then on the right is a white circle. Can you find it in my net? Well, you can, okay, it's over here, right? Okay, so if that's the case, now I want to look for the front face. Should I look for direction 1, direction 2, or direction 3? Which direction should I look for the front face? Which direction should I look at to get the front face? Type it in the chat below. Which direction should I look for? Should I look for 1, 2, or 3? Okay, be careful. I'm just asking which direction to look for. Okay, some may say 1, some may say 3, and just nice there are 2 triangles over here. But then again, think about rotating the arrows. If I rotate the arrows just now, my red arrow is to the right and my blue arrow is going down. Now, if my red arrow is rotated so that it is now pointing to the top, where should my blue arrow be pointing to? 1 or 3, try rotating the 2 arrows together. If you rotate it, you will see that the direction is direction 1. Okay, if I rotate the red arrow to point to the top, then the blue arrow should be pointing to the right. It's just rotating the arrows. So I should look for direction 1. But the problem is there any face over here? There's nothing. Does that mean I cannot form the cube? Actually not. This is because the face is actually over here. Okay, when I try to fold the cube, the face to the right of this face comes from this part, the triangle over here. It's just that we need to be careful. How is the direction of this triangle when we fold the cube? Okay, so how should we actually do that? We will check part by part. I cannot just directly copy down and then say, oh, this is the face, how it looks like over here. Cannot. All right, take a guess. If I want to fold the cube, if I want to fold the cube, which side of this face, which edge will overlap or coincide with this blue edge over here? Okay, is it edge 1, is it edge 2, or is it edge 3? Okay, nonsense. You guys are getting naughty in the chat. Okay, pay attention. I know who you are. All right. So, some of you are saying answer is D. Okay, indeed the answer is D. But why is it the case? This is because actually, this edge will overlap with this edge. Okay, and if I try to fold it together, actually I will need to find out what does the face look like over here. I don't copy whatever is over here. I just rotate it. Okay, I will just rotate this face 1 time clockwise and I will get a pattern like this. Okay, so the black triangle on the top left, white triangle on the bottom right. So this is what the face will look like under the white circle. But now I need to check under this rectangle face, what does this triangle face look like? So I will need to rotate again. So rotate again. Okay, and you are able to get another rotation. Okay, 1 time clockwise. This time I will get a face that has the black triangle on the top right. So just rotate it 2 times clockwise. Okay, rotate clockwise, rotate clockwise. So you will get something like this. And let's check. If I look at these 2 faces together, all right, so, and I rotate it so that I get my top face like what is shown on the cube, something like this. Okay, the black rectangle on top. Then what will the bottom face look like? If I rotate it, it will actually look something like this. Okay, it will look like this. But do they match? Well, they don't, right? This one, the triangle is on the left. This one, the black triangle is on the right. So I know C is definitely also not my answer, which means my answer must be D. But what's my answer D? Let's have a quick check, shall we? Okay, so let's check the answer for D. Okay, for D, we have a vertical black rectangle, vertical white rectangle, and to its right, we have a black circle. Can you find this face on the net? Is it on the top or at the bottom? Well, it is on the top, right? So these 2 faces, they are adjacent to each other as shown by this cube. So all I need to do is find out what is the face showing at the front. Okay, so as usual, I will consider the direction over here, direction 1. But there's no face over here. How do I get this face? Remember what I said just now for option C? We will rotate this actual face on the left. Okay, rotate it counterclockwise. Sorry, is it counterclockwise? No, it's clockwise. Rotate it clockwise this time to go up. Okay, and then see what will become the pattern under the rectangular face. Okay, and it is actually something like this. Okay, it looks something like this. Okay, if I rotate this face clockwise one time, this time my black triangle will be on the bottom left. But we should look at this direction, look from the top to bottom like this. In other words, this face is not what it will look like when I put the cube like this. Okay, remember the top face is over here. I should look through this direction. Okay, to the left. And then you will notice that, oh, the two faces, they look exactly like what is shown on D. All right, so it will look something like this. And yeah, that matches with our answer D. So we know that D is the correct answer. Now, this type of question, a lot of parents, a lot of you have actually asked me to give you extra questions. So remember the extra questions I've given you on Sunday. Yes, you can try more of these questions in that extra problem sheet. And if you have any question, feel free to reach out to me and I will explain them to you. All right. So when we are matching nets and cubes, yeah, this is how we do it. Okay. So yeah, now let's take a look at question 15, shall we? Question 13 seems like most of you are confident. You all are spamming answers here and there. Let's look at question 15 instead. Okay, for question 15, Jennifer is forming the following solid using several cubes. We are gluing the cubes together, okay? She then glued the solid or pasted the solid onto the ground, and then I painted the entire solid pink. First of all, she put the solid onto the ground, glued to it so that the base of the solid is pasted onto the ground. Then she painted the entire solid pink. The question is, how many faces of the cube were not painted? Okay, so this is not counting cubes, this is counting faces. Okay, so do you all have your answers? Okay, what answers are there? Some of you already gave me your answers. The correct answer. So let's just check. How do we get faces with not painted faces? How do we get faces that are not painted? Okay, you see, we have two cubes over here. Let's say I paste them together. Okay, my hands are the cubes. I paste them together and I actually paint the entire surface with some color. How many faces of these two cubes are not painted? Some might think it's one, right? Because I only touch them at one side. But actually, if you try to separate them away, you will see that there is one face that is not painted here, another face that is not painted here. So two cubes pasted together. After I paint them, there are two faces, which are these two, that are not painted. In other words, for every pair of cubes that are touching each other, we will have two faces that are not painted. So this is what we call the touching pairs. Each pair of touching pairs will have two unpainted faces. Okay, so you can take a look at this diagram over here. Where are my unpainted faces? Where are my touching pairs? Well, one of them is very clear to you, right? It's over here from the left to the right. Okay, let me change my color. This is a touching pair, right? This is a touching pair. So this touching pair is sideways from the left to right. How many sideways touching pairs are there? Is there only one? No, actually, because if you notice, this is 2 cubes tall, this is 2 cubes tall. Two of these towers are pasted next to each other. So how many touching pairs should come from these two towers? There are 2 touching pairs coming from this tower. All right, so there will be 2 touching pairs, but is that all? How many touching pairs are there from left to right? From left to right, are there only 2 touching pairs? Okay, are there only 2 touching pairs? Some say 2. Are you sure? Are you sure it's 2? You see, we know that there is a hidden cube over here, right? Is this hidden cube only sticking to the cube on the right? How about the cube on the left? You see, these 2 cubes, this left cube and the hidden cube, there is another touching pair. Right, so how many touching pairs from the side are there actually? Side by side, there are 3 touching pairs. Okay, 3 touching pairs. Okay, okay. Now, my question is, can I only from touching pairs from side to side? Or are there any other ways to form touching pairs? Somebody said 10. Are you sure there are 10 touching pairs? There aren't. Okay, let's see. Besides side by side, how about front and back? Right, there are also touching pairs that can be front to back. And very obviously, you can see from the front to the back, there is one touching pair over here. From the cube at the front to the hidden cube at the back. So if we are talking about touching pairs from the front to back, there is one pair. Okay, and how about from top to bottom? You can stack the cubes together, right? These two are also touching faces. Okay, you also have two touching pairs from top to bottom. How many are there? You just need to count how many towers are there with more than one cube. Take a look at these two cubes. They are touching each other from top to bottom, right? So there will be one touching pair from the top to the bottom. Is there another tower with two cubes? Just next to it, there's another tower with two cubes. Okay, so from top to bottom, we will see that there are two. Whoa, very ugly. From top to bottom, there are two touching pairs. So altogether, how many touching pairs are there? How many touching pairs and how many unpainted faces do we get from the touching pairs? There are 3 plus 1 plus 2 equal to 6 pairs. But does that mean 6 touching pairs means 6 untouched face or unpainted faces? Are there 6 unpainted faces over here? If I have 6 touching pairs, how many unpainted faces are there? Only 6? Remember, one pair is how many unpainted faces? 2, right? So 6 pairs, how many unpainted faces are there? 6 times 2 equals 12. 12 unpainted faces from the touching pairs. Oh, it's just 12. Okay, it's my answer C, everyone. It's my answer C. If somebody says, oh, my answer is C, 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 read the question again. She pasted the solid onto the ground and then painted the solid pink. Imagine if you paint the solid, but before that, you paste it onto the ground first. If you paste the solid onto the ground and then paint it, do you think the bottom surface will be painted? No, right? The bottom surface will not be painted as well. So other than that, we need to consider how many faces are there in the bottom. Because at the bottom, the faces will not be painted. It's already sticked onto the ground. And how do we count the number of bottom faces? Can we just rotate the solid and then count? Maybe not. I mean, you can just see the picture over here. You don't have the actual solid to work with. What's the skill to calculate the number of bottom faces? Okay, here's a little magic for you. So here we have this solid over here. How many faces can you see at the top? Okay, let's count with me together. How many faces are there at the top? The orange faces, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have 9 faces at the top. So take a guess. How many faces at the bottom will there be? Okay, I have 9 faces at the top. Guess how many faces from the bottom will there be? Okay, I'll give you 10 seconds to think about this. And yeah, 20? Really? Maybe not, okay? Let's try to rotate this diagram to the bottom. Aha, now you see the bottom faces. Okay, these are the bottom faces. And how many faces at the bottom are there? Right, I see the correct answer. Good job. 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 9 faces at the bottom as well. So you can see that the number of faces at the top and at the bottom, they will be the same, right? So if we want to calculate the number of bottom faces, we just need to count how many top faces are there in a diagram formed with cubes. So how many top faces are there? Type it in the chat below. How many faces on top are there? Is it 9? Look at this diagram. How many are there? There are 1, 2, 3, 4. So there are actually 4 bottom faces. And since there are 4 bottom faces, these 4 faces will also be unpainted. Right? Good job, everyone in the chat. Yep, there are 4 faces at the bottom that are also unpainted. So in total, how many unpainted faces are there? Hint, the answer is not C. I have 12 faces from my touching pairs, 4 faces as my bottom faces. 12 plus 4. How many faces are there in total? Is my answer D? No. Okay, 12 plus 4 is 16. Okay, so my answer is B. All right, so I know that this question is very complicated, but if you are from CO or CO prep, okay, hopefully you did this question correctly. We did this not that long ago. When we want to count the number of unpainted faces, we look for two things. First, how many touching pairs are there? One pair gives me two unpainted faces, okay? So then we consider from three directions, the front to back, okay, like these two over here, side to side, okay, or top to bottom. Three perspectives. Also, if the solid is glued to the ground, pasted to the ground, remember to also consider bottom faces. How many bottom faces are there? And you don't need to rotate the solid. You just count how many faces are there at the top, and you will get the number of faces at the bottom. Okay, add the two number of faces together to get the total unpainted faces. Well, the second one only holds if it is glued to the ground. If it is not, then you don't need to consider the bottom faces. Okay, I repeat, if it is not glued to the ground, you don't need to consider the bottom faces. They will also be painted. Only if the solid is glued to the ground, okay, it will be unpainted. All right, so with that, let's take a look at section B. Okay, for short answer questions. Section A, the questions, I see that most of you are fine. Okay, let's take a look at section B, starting with question 17. Haha, okay. Tell me your answer for question 17. Okay, while I read the question, if you know the answer for this, type it in the chat below, all right? Figure 1 shows different colored stickers pasted by some children. They are red, green, yellow, and blue. Anna made a record of the number of hearts of different colors in each section, as shown in figure 2. Using figure 1, find the question mark in the equation below. Oh, I see somebody giving me the answer already. If you can, give me the full equation. What are these four numbers? Okay, what plus what plus what minus what equals your answer. Okay, and for those who couldn't get it, let me explain what's going on. So basically, each figure represents a certain number of hearts. Okay, for example, in the first part, we have the green diamond over here. Green diamond means how many green hearts are there in this diamond? So let's count together. 1, 2, 3. Okay, so since there are 3 green hearts in this diamond, all right, so there are 3. So this number or this symbol represents 3. Okay, and how about the blue big triangle? The blue big triangle, no, the answer is not 17, okay? Blue big triangle, okay, since it is the blue big triangle, we look for the number of blue hearts in the big triangle. 1, 2, 3, 4, 5, 6. So there are 6, okay, of the blue hearts in the big triangle. 1, 2, 3, 4, 5, 6. Okay, so there are 6 in total. And look at that. 3 plus 6 is just 9. All right. So this is how we are supposed to do this question. We just need to figure out how many hearts are there for the corresponding color in the corresponding section. Okay. So first of all, number 8. Can you tell me what is this number 8? How many blue hearts are there in this diamond? Oh, somebody already gave me the full equation. Good job, good job. Okay, so you can see that for the blue diamond, there is 1, 2, 2 blue hearts. So this number is 2. Okay, how about the next number? Number B. How many yellow hearts are there in this triangle? 1, 2, 3, 4, 5. Okay, there are 5 yellow hearts in the triangle. So 5 of them. Okay, now let's take a look at the red part. Okay, the red part in the circle that is not part of the diamond or part of the triangle. How many red hearts are there? Let me change my color and let's count together. There are 1, 2, 2, and 3. 3 red hearts. So this number is 3. Okay, good job, good job. Keep the answers coming. Okay, how about the green small little part over here. How many hearts are there which are green in this small little part? There are one, two hearts. Okay, so 2, 5, 3, 2 is my answer. 2 plus 5 plus 3 plus 2 equals 12. Can I say my answer is 12? Right, I just add all the numbers up, right? Is my answer 12? Or what is my answer? Okay, what do you think is the answer? Is my answer really 12? Yeah, I see some very careful kids out there. No, the answer is not 12, okay? Because, right, if you take a look, this is actually a minus sign. So it is actually 2 plus 5 plus 3 minus 2. And what is the final answer? This is not plus different colors in the section. So given a section, just count how many hearts of that color are there in the section. Okay, for example, yellow in the circle, just count how many yellow hearts are there. All right, so this is more of a understanding comprehension question. Okay, so hopefully you are fine. Okay, so with that, let's move on to question 21. Question 21 is very difficult. Okay, so let's see. What is the largest three-digit multiple of 3 without any repeating digits? So I want a largest number. It is a three-digit number. It is a multiple of 3, and there are no repeating digits. No repeating digits means, can I say my number is 111? Okay, is my answer 111? Right, the last question, the answer is 8. How about this question? Do you think I can say 111 is a number that I want? Oh, I see some answers given to me. Very good. Okay, but to answer my question just now, I cannot say 111 because I repeated digits over here. Okay, I want a number that does not have digits repeated. Okay, so each digit must be different. And there's another question. What does multiple of 3 mean? Right, if I say multiple of 3, can you all give me examples of multiples of 3, please? What examples are there? Okay, of course, the answer is an example. Any other example? Small ones, okay? For example, 3 times 1 is equal to 3, right? So 3 is a multiple of 3 because I multiplied 3 by another number. If I multiply 3 by another whole number to get a different number, that different number is a multiple of 3. For example, 3 times, whoa, for example, 3 times 2 is equal to 6. I multiplied 3 with another number 2 to get 6. So 6 is also a multiple of 3. And likewise, 9, 12, 15, these are all multiples of 3. Okay, so, oh no, it's not 3 to 1 times 3. Okay, be a bit more careful. All right, so let's take a look at another warm-up. We all know that 27 is a multiple of 3. Okay, because 9, whoa, spoiler, because 9 times 3, 9 times 3 is equal to 27. Now, my question is a multiple of 3. What is the next multiple of 3? After 27, what is the next multiple of 3? Type it in the chat below. Multiplying numbers by 3. After 27, what is the next multiple of 3? No, it's not the answer yet. Multiple of 3. What is the next multiple of 3? No, 10 is not the multiple. In the equation here, 27 is a multiple. So somebody say 10. I think you might be doing 10 times 3 equals 30, right? So 27 to 30. Okay, so how do we get 27 to 30? Other than doing 10 times 3, again, because after 9 is 10. To get from 27 to 30, what actually happened? I think we added it with a certain number, right? 27 plus what is equal to 30? 27 plus what is equal to 30? That magic number is everywhere in this slide. Okay, 27 plus 3 equals 30. Right, yeah, 30 is the next multiple, and thank you for answering. 27 plus 3 is 30. Okay, so if I want to find the next multiple, all I need to do is plus 3. So after 30, the next multiple will be 33. And how do I get that? Other than doing 11 times 3, I just do 30 plus 3. Okay? So that's one question over here. How about this? What is the previous multiple of 3? Right? Just now we said we have 9 times 3 is equal to 27. This is the multiple. What is the previous multiple? The multiple before 27. Before 27, what is the multiple of 3? The previous multiple of 3 before 27. Type it in the chat below. Think about it. If I want to find the next multiple, I will plus 3, right? If I want to find the previous multiple, the multiple before that, do I still plus 3? Or what should I do instead? What operation should I use? Yeah, someone listed out the multiples of 3. Okay, that's impressive. Okay, do I still do plus 3? No, right? I should minus 3 this side. To get the previous multiple, I will subtract the current multiple by 3. And I will get 24, which is just nice. 8 times 3 is 24. Right, 8 times 3 is 24. And if I want to continue finding the previous multiple, I'll just subtract it by 3 again. And I will get 7 times 3 equals 21. That's another previous multiple. So what do you notice in this question? Okay, the key moral of the story I want you to know from these two questions is that if I want to find the next multiple, I just use addition. Add the number that is given to you. If it's multiple of 3, then you plus 3. If I want to find the previous multiple, I will minus 3. Wow, I see minus 3 is in the chat all over. Right, that's right. Okay, it's minus 3. To find the previous multiple, we will minus 3. Okay, now let's get back to the chat, or rather the question over here. What is the largest 3-digit multiple of 3 without repeating digits? Wow, that's a lot of conditions. It's okay, let me make the question simpler first. Whenever we see a lot of conditions, we try to go through them one by one. Okay? So my first question, what is the largest 3-digit number? The largest 3-digit number, very easy, okay? Everyone knows the number. What is the largest 3-digit number? Is it 1,000? Is it 100? Largest 3-digit number. What do you think it is? Yes, good job. It is 999. Right, 999 is my largest 3-digit number. That's right. And is 999 a multiple of 3? Is it a multiple of 3? Yes or no? Type it in the chat below. Okay, is it yes or is it no? Is 999 a multiple of 3? Such a beautiful number. Surely, is it? Okay, 999, it is a multiple of 3. That's a yes. Okay, why is it the case? Because 999 can be written as 9 hundredths. All right, 9 hundredths plus 9 tenths plus 9 ones. Okay, so if that's the case, 9 hundredths, 9 is a multiple of 3. It divides 3 into 3 hundredths. Okay, after getting divided by 3, 9 hundredths becomes 3 hundredths. 9 tenths becomes 3 tenths. 9 ones becomes 3 ones. So actually, 999, it is a multiple of 3. Okay, 3 times 3. So it is a multiple of 3. That's a very big yes. But then, can I just say my answer is 999? Right, largest 3-digit multiple of 3. Hey, don't be that fast yet, okay? Because remember, I still have one more condition to check. That is without any repeating digits, okay? No 2 digits can repeat. So in 999, we have 3 nines. We repeated 9 3 times, okay? So obviously, we cannot choose this as the answer, okay? Cannot choose this because it has repeating digits, okay? If that's the case, let's find the next largest 3-digit multiple of 3, which should be the smaller multiple. Before 999, what is the next largest multiple of 3? Should I plus 3 or should we minus 3? If you think I should do plus 3, type A, plus 3. If you think I should do minus 3, type B. should I do plus 3 or minus 3? Okay, a lot of you have already given me the answer. Okay, should I plus 3 or minus 3 to find the next largest 3-digit multiple of 3? Right, we should minus 3 because I want to find the next largest. Okay, next largest means I'm finding slightly smaller numbers. So I actually find the previous multiple before 999. The previous multiple is 999 minus 3, which is 996. Can we stop yet? Cannot, right? Okay, you see 9 and 9, so we cannot stop here. Let's continue to minus 3 again. 996 minus 3 gives me 993. Okay, but then is 993 an acceptable answer? Still not. I still see 2 nines. I don't want repeated digits. Let's continue to minus 3. Minus 3 gives me 990. Hey, there's still 2 nines. Okay, what should we do? Don't give up yet. Okay, let's continue. Minus 3 again. What do we get this time? 990 minus 3. What does this give me? Okay, remember to find a previous multiple, we should use minus and not plus. Okay, right, we get 990 minus 3 is 987. Okay, so 987 this time, look, the 3 digits, are there any repeating digits? No, right? All digits are different. So my answer can be 987. Okay? So yeah, that's how we find the answer. If you see a lot of conditions, you search for a number and there are a lot of conditions, we just start from one of them and then we gradually try to fit into the other conditions. And to find the next multiple, we will add. To find the previous multiple, we subtract. Okay? Now, are you ready for the big boss question of the day? Okay, question 22. Are you ready? Okay, question 22. So many of you have asked me how to do this question. This question is too hard because it's similar to question 21. We have some conditions, okay? So if you are in this live stream, please pay attention, okay? Question 22, very difficult. But this is something that could come up in P2 TASMO. Right. Okay, so pay extra attention over here. Henry tries to list out all of the 3-digit odd numbers. Some of you will miss out the detail. Odd. You all just see 3-digit numbers and you forgot the odd. Right. Okay, this could happen, right? Whose ones digit is a multiple of the tens digit? What does it mean? Ones digit is a multiple of the tens digit. Ones digit is the multiple. So actually, what we should do is, it means tens digit times a certain number gives me ones digit. Ones digit is a multiple of the tens digit, means tens digit times a certain number gives me the ones digit. That's why ones digit is a multiple. It's the number that we get after multiplying. Okay. Oh, so confident. You're spamming the chat. Okay. So how do we do this? First of all, like I said, so many conditions. Let's take a look one by one. Okay. We are looking for the 3-digit number. So it has a hundreds place, tens place, and a ones place. Okay. So we know it has 3 places. Next, we know that it is an odd number. If I want odd number, can you tell me what can my ones digit be? Type in the chat below ones digit for an odd number. What can they be? Ones digit of an odd number. Don't just give me the answer. Listen to my question. Ones digit of my odd number. What can they be? Yes, very good. It can be 1, 3, 5, 7, 9. Right. Okay. So each of the possible numbers as my ones digit for my odd number. 1, 3, 5, 7, 9. Okay. Now, let's consider one by one. If my ones digit is 1, what can my tens be? Can it be any number? Cannot, because remember, ones digit is a multiple of the tens digit. So, tens digit times something will give me my ones digit. So, if my ones digit is 1, I need something times something, or rather, let me do it with brackets. Something times something is equal to 1. Can you tell me what can my tens digit be? or what numbers can be filled inside these brackets. If my ones digit is 1, something times something equals 1. What can this tens digit be? Can it be all of 1, 3, 5, 7, 9? Are you sure? 3 times what equals 1? Right, only one consideration. 1 times 1 is equal to 1. I see the answer in the chat. Good job. All right. 1 times 1 is equal to 1, which means my tens can only be 1. Okay? Similarly, if my ones is 3, how many times how many is equal to 3? Okay, what can go into these brackets? Just now, 1 times 1 is equal to 1. So my tens can be 1. How many times how many is equal to 3? Look at your times table. Where do you get 3? Where do you get 3? How many times how many equals to 3? That's right. It's actually 1 times 3 equals 3, which means my tens can be 1, but also it can be 3. Right, 3 times 1 equals 3. 1 times 3 equals 3. So when my ones is 3, there are 2 possible digits for my tens digit or tens place. Okay, for 5, it's similar. 1 times 5 is equal to 5. So I have 1 and 5. 7, 1 times 7 equals 7. That's my only possibility. So my tens can be 1 or 7. Now for 9, you might say, oh, 1 times 9 equals 9. Okay, so my tens can be 1, can be 9. Is that all? Can I just say 1 times 9 equals 9? So my tens can only be 1 or 9? Can my tens only be 1 or 9? Think about it. 1 times 9 equals 9. So my tens can be 1. My tens can be 9. Is that all? Okay, I see some good answers in the chat. You all reminded me 3 times 3 is also equal to 9. 9 is also a multiple of 3, which means my tens digit can also be 3, right? Yeah, 1, 3, 9. So now we find out for each possible ones digit, what are the tens digit that we can use. So if that's the case, then let's consider tens and ones combined together. What possibilities do we have? We have 1, 1, so 11, or rather 1, 1, 1, 3, 3, 3, so 1, 3, 3, 3, 1, 5, 5, 5, so 1, 5, 5, 5, 1, 7, 1777 over here. And finally, 193999. Don't forget your 3 nines, okay? So in total, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ways to choose your tens and ones. But how about the hundreds? Did I mention anything about the hundreds? How many ways can we choose my hundreds digit? Type in the chat below. How many ways to choose my hundreds digit? Okay, how many ways can we choose my hundreds digit, everybody? Somebody said 10. Are you sure? Did you consider all of 0 to 9? Can 0 be at the highest place? Remember what I said last week? Cannot, right? Yeah, so how can I choose my hundreds place? It can only be 1, 2, 3, or 4, or 5, or 6, or 7, or 8, or 9. How many hundreds digits are there? How many ways are there to choose the hundreds digit? Just ways, right? So we have 9 ways to choose the hundreds digit. 9 ways to choose it. And for each way to choose the hundreds digit, we have how many ways to choose the tens and ones? 9 ways to choose the hundreds. Let me erase a bit. 9 ways to choose the hundreds. For each way, 10 ways to choose the tens and ones. Each hundreds digit has 10 ways to choose the tens and ones. If there are 9 hundreds digits, how many ways in total are there to form this number? Yep, 9 ways to form my hundreds digit or to choose my hundreds digit. How many ways are there to form the entire number? Each hundreds digit has 10 ways to choose the tens and ones. If I have 9 hundreds digit, the total number of ways will be 9 times 10 equals 90. So in total, I have 90 numbers that I can list out. All right, each hundreds digit has 10 ways. So 9 times 10 equals 90. Okay, so for this question, whenever we try to choose suitable numbers, we start considering the possibilities for the pickier digits first. For example, over here, the pickier digit is the ones digit because it must be odd. Okay, and then ones digit is a multiple of the tens digit. From there, we decide what's the tens digit. Then finally, there's no restriction for the hundreds digit, so just lists out every possibility, right? So in total, there are 90 ways. Okay, are you clear with this question? Okay, if you are clear, let's perhaps move on to question 24. Now, question 24, it is a vertical addition and subtraction number puzzle. Okay, if you are CO kids, CO prep, okay, hopefully you still remember how to do this, all right? So you see, IS plus IS plus IS plus IS equals PI. All the different letters stand for different digits. Let me highlight it better. All the different letters stand for different digits. Okay, what is the value of PI? So normally when we do vertical addition, we start from the right, right? Okay, but oh, somebody said this is easy. What's your answer then? We start from the right usually, but look, no numbers are given to us. Do we know anything by looking at the right column? Maybe not. So let's actually start from the left instead. Start from the highest place. In fact, this is the tip I want to give you. Whenever there is nothing over here, maybe instead of starting from the lowest place, we can also consider starting from the highest place. Right. So if we start from the highest place, what do we have? We have I plus I plus I plus I equals P. Or, there could be some carryover in the front. Okay, but let's not care about carryovers. We just know that I plus I plus I plus I plus maybe some carryover will still give me a digit P. It is still a one-digit number. So what could I be? Okay, type in the chat below what could I be. Okay, nonsense, nonsense. If you think this is nonsense and you see something in the competition, you can't do it. I can't blame you, okay? So pay attention. So I plus I plus I plus I, it still gives me a one-digit number, P. 84? Try again, all right? It's not 84. So think about it. Can I be 1? Well, if I is 1, 10 plus 10 plus 10 plus 10 gives me 40. It's still a two-digit number. So maybe I can be 1. How about I equals 2? Can I be equal to 2? Okay, I can be equal to 2 because you see, if I do 20 plus 20 plus 20 plus 20, it gives me 80. So it's possible that I is 2. I can still get a two-digit number when I is 2. What if I is 3? Can I be 3? Can I be 3? I cannot be 3. Why? Because even if I start with the smallest two-digit number that starts with 3, 30. 30 plus 30 plus 30 plus 30 is already 120. That's already a three-digit number. So of course, I cannot be 3. We do not consider this because that's too large. So I can only be 1 or 2. But how do we know whether I is 1 or 2? Okay, so you see, I consider this I, this I, this I, this I. Is there any other I's that I can consider? Yes, there's one at the result for the ones digit. So we have S plus S plus S plus S equals, pay attention, it's not I. There could be a carryover. So I can only say something I. It could be I, it could be 10 plus I, 20 plus I never know. So it's something I. S plus S plus S plus S equals something I, and you're saying I is 2. Wow, so fast. That's right, because think about it. S plus S plus S plus S, so many repeated addition. I can turn it into multiplication and just write 4 times S equals something I. Okay, so then 4 times S equals something I. Look at your times table. Can 4 times S equals something 1? Is there an S such that 4 times S is something 1? No, right? Yeah, if you try to recite your times table, there is no something 1 in the times table. There is only something 2. Right? So I must be 2 because 4 times s can only be something 2, cannot be something 1. If that's the case, 4 times s is something 2, what can my s be? There are 2 possible values, okay? Don't just say, oh, 4 times 3 is 12, s is 3, I'm done. Is it only 3? What values can s be? When s is 3, of course, 4 times 3 is equal to 12. That's correct, right? 4 times 3 is equal to 12. When s is another number, 4 times that number also gives me something too. What is that number? That number is 8, right? Okay, somebody said non-existent really. 4 times 8. 4 times 8 is 32. Okay, so 4 times 8 is 32. So it's again a something 2. So s can be 1. S can be 3 or s can be 8. So I know that my I is 2. Let's just first replace all the I's with 2's. All the I with 2. Okay? Now, let's check. S is 3. If S is 3, then what is 4 times S? 4 times S is 12, which means my carryover here should be 1, right? 3 plus 3 plus 3 plus 3 equals 12. I write down 2 over here and my carryover is 1. So if my carryover is 1, will these 5 numbers, 1, 2, 2, 2, 2, add to a 1-digit number? Let's check. 1 plus 2 plus 2 plus 2 plus 2 equals, okay, quick calculation. S is 8. Let's check if S is 8, okay? And for somebody who is asking me to explain again, don't worry, there will be a playback for this live stream available later, so you can look back for the explanation, okay? And if you still need any clarification, you can ask the teachers in the group chat, okay? So the sum is 9. And look, it's a 1-digit number. So I can confirm P can be 9. P can be 9. So my answer is 92. Right. Let's quickly check. What if S is 8? Somebody says S is 8. If S is 8, right, then 8 plus 8 plus 8 plus 8, what does this give me? This gives me 32 instead. So instead of a carryover of 1, I have a carryover of 3. Okay? But then 3 plus 2 plus 2 plus 2 plus 2. 3 plus 2 plus 2 plus 2 plus 2 gives me 11. Oh, it's not a 1-digit number anymore. So can I say that S is 8? S cannot be 8 because P only represents 1 digit. It cannot represent 11. So this case is rejected, which means S must be 3, P must be 9, I must be 2. Answer is 92. Okay, for those who are very confident, hey, I know how to do. Okay, good job. Okay, hopefully when you see similar questions in the future, you always know how to do, all right? So, final question of the day. Let's end off this live stream with something easier, okay? Among all the 3-digit numbers, wow, 3-digit numbers again, but trust me, this is easy, okay? Among all the 3-digit numbers, whoa, that can be formed using the digits 0, 1, and 3 without repetition. Again, I cannot repeat my digits. Okay, among all the 3-digit numbers that can be formed using 0, 1, and 3 without repetition, what is the difference between the largest and the smallest 3-digit numbers? Okay, so I am finding the difference between 2 numbers, not just any number, but the largest and the smallest 3-digit numbers. What is the difference? Okay, so if you know the answer to this question, can you type it in the chat, please? What is the largest number, the smallest number, and the difference? Okay, for those who don't know, it's fine because let's take a look. We have 3 digits, 0, 1, and 3. We don't want to repeat the digits and we want to use them to form 3-digit numbers. My tip to you is to start from small to large. Okay, don't randomly list them. List them in order from small to large. Now, remember what I said in last week's live stream? If I want to form a smallest number, should I focus more on the digit on the left or the digit on the right? Should I focus on the digit on the left or the digit on the right? In other words, 3-digit numbers, hundreds place, tens place, ones place. Do you think the hundreds place plays a larger role or the ones place? The hundreds place plays a larger role, right? So we have to assign the smallest digit possible for the hundreds place. Oh, the smallest possible is The smallest possible digit is 0. Can I just say 013 is my smallest 3-digit number? No, okay. In fact, somebody told me what is the smallest 3-digit number available in the chat. Good job, okay. Now, 013, we cannot do that because remember, I said this last week. I'm going to say it again. 0 cannot be in the highest place. So I cannot start with 0 in my hundreds place. I should consider the next smallest number. And what is the next smallest number? The next smallest number is 1. So I should start off with 1 at the hundreds place. So what is the smallest 100 number above 100 that we can form using 0, 1, and 3? What is the smallest 3-digit number? Oh, somebody listed it out. Very good. But try to list it in order, small to large. Okay, the smallest number is the next digit. Again, we start small, put 0 first, and then 3. So it is 103. Okay, how about after 103? What is the next smallest number? Can I straight away jump to 300 and something? Maybe not. Check again. Are there still any numbers that start from 1? There is 130. Okay. Now, next number. Can I still find a number that starts from 1? Oh, maybe 133, right? Okay, but wait, be careful. Without repetition. So can I put 2 3s next to each other? Cannot. I cannot repeat the digits. Right. So what is the next number I should consider? Maybe I should consider 300 something instead. So what are the next numbers that I can write? After 103, 130, I should do 300 and that's right, 301. Okay, so 301 and finally 310. Okay, any more numbers? Cannot. All right, we are only stuck with 3-digit numbers. So these are the 4 3-digit numbers we can form using the digits without repetition. So what is the answer? We want to find the difference between the largest and the smallest 3-digit numbers. Okay, so the 3-digit numbers, the largest one is 310, as you all mentioned in the chat. The smallest is 103, and we minus them, find the difference, and this gives me 207. Okay, so my answer is 207. Somebody really gave me very detailed explanations. That's very good. And yeah, that's the answer for question 25. Remember, when we are forming numbers, list them from small to large. This is what we call dictionary arrangement. Okay, follow an order like what you see in the dictionary. Okay, so I guess that's all for today. So if you have further questions, feel free to ask them in the group chat. Okay, playback will be available soon. Okay, and you can either ask any other questions you have in the group chat, or you can reach out to our teachers. All right, so in the next coming week, okay, Tuesday, we will still have another live stream. I will give you all some final reminders on both problem solving and taking the TASMO exam in general. Okay, for example, what should you prepare? How do you fill in the answer sheets? Okay, what careless mistakes should you avoid? Okay, and so yeah, with that, that is the end of our Tuesday evening together. All right, so for those of you, especially those who have been very active and polite in chat, okay, thank you so much. And yeah, I will see you when I see you again. All right. So yeah, have a restful evening. Okay, goodbye. Okay. All right. So yeah, I'll see you when I see you again. And oh, by the way, I will post the solutions later, all right, in the group chat. So stay tuned for that as well. The full solutions for all the questions. Okay. All right. So yeah, for those who are still staying, if you have any questions, you can raise them in the group chat. Or you can reach out to our teachers.